All right, today we're going to talk about something we all rely on constantly, but probably don't think about nearly enough: lubricant oil. Seriously, it's the lifeblood of pretty much any machine with moving parts. It's this unsung hero quietly doing its job inside your engine. But what is it actually doing in there? Let's find out. I mean, just think about that for a second. Inside an engine, you've got metal grinding against metal at insane speeds, generating a ton of heat and friction. It is a really brutal environment. So what's stopping that whole thing from just seizing up and turning into a useless block of metal? Yep, it's just a few quarts of oil. Okay, so here's our game plan. First, we'll cover all the different jobs oil has. Then, we'll peek inside a drop of oil to see what it's made of. After that, we're going to learn to read the bottle, to speak the language of lubricants by decoding all those specs. And we'll wrap it all up with some practical know-how you can actually use. So first things first, let's get one thing straight. This is so much more than just some slippery stuff. Oil is a highly engineered liquid, and it's performing a whole bunch of critical tasks all at the same time. You know, the list of jobs this stuff does is just wow. Of course, it lubricates, right? It reduces that friction between all the moving parts. But it's also a coolant, pulling intense heat away from critical spots like the pistons. And it's a cleaner. It actually grabs onto tiny bits of soot and metal particles and holds them so they don't scrape things up. It's also a protector, creating a film that stops rust and corrosion. It even acts as a sealant, filling in the tiny gaps between piston rings and cylinder walls to keep compression high. It is a true multitasking genius.
So, how in the world can one single liquid do all of that? Well, to figure that out, we've got to look at what's actually in a drop of oil. The secret, as you might guess, is all in the chemistry.
At its heart, every motor oil really just boils down to two main components. You've got your base oil, which makes up most of the volume and gives you that fundamental slipperiness, and then you've got the additives, and that's where the real magic happens. So this stuff starts its journey deep underground as crude oil. It gets pumped into a refinery, heated up, and distilled. They separate out things like gasoline and diesel fuel. The stuff that's left over goes through a ton of extra processing to become a really pure, stable base oil. Then, finally, that base oil gets blended with a very precise cocktail of those additives to create the final product you see on the shelf. And this is why those additives are so critical. They're what turn a simple lubricating oil into a high-performance machine protector. You can think of them like a specialist team. You've got one additive that's a detergent to keep things squeaky clean, another that's an anti-wear agent to protect surfaces, maybe a third that stops the oil from getting all foamy. Altogether, they give the oil its incredible superpowers. Okay, now that we know what's in the oil, let's learn how to speak its language. You know all those letters and numbers on the bottle? They're not just random. They're a code that tells you exactly what that oil is designed to do, and we're going to crack it. Now, this language isn't just made up. It's governed by a few major organizations, and seeing their symbols on a bottle is basically your guarantee of quality. You've got the API, the American Petroleum Institute, which sets the performance standards. Think of that like a report card for how well the oil protects an engine. Then there's the SAE, which defines the oil's thickness or viscosity. For industrial stuff, the ISO does something pretty similar. All right, let's get to the fun part. Let's decode the most important specs you'll see. We're going to turn these technical terms into real-world knowledge you can actually use next time you're in the auto parts store. This is probably the single most important property of any oil. It's viscosity. Put simply, it's just a measure of how thick the oil is or its resistance to flow. So, high viscosity means it's thick, kind of like honey. Low viscosity means it's thin, more like water. And getting this right is absolutely critical. If it's too thin, it won't create a strong enough protective film, but if it's too thick, the engine has to work way harder just to pump it around, and that just wastes fuel. But here's the catch, right? Oil gets thinner when it gets hot. The viscosity index, or VI, tells us exactly how much it thins out, and a high VI is a very, very good thing. It means the oil stays more stable whether your engine is ice cold or running hot. Think about it. An oil with a low VI could leave your engine almost unprotected for those first few critical minutes on a cold morning, and that's when most engine wear happens.
For industrial oils, the system is even simpler, which is nice. The ISO viscosity grade, or VG, is just a number, and the higher the number, the thicker the oil is at a standard temperature of 40 degrees Celsius. So it's pretty obvious that an ISO VG 68 is a lot thicker than an ISO VG 32. It's that easy.
So oil also has its limits on both ends of the thermometer. On the hot side, you have the flash point.
That's the lowest temperature where the oil gives off enough vapor that it could ignite. Super important for safety. On the cold side, you have the pour point. That's the absolute coldest temperature where the oil can even flow. If you're starting a machine in the dead of winter, you better believe you need a low pour point.
Okay, now this one is a big deal, especially if you're dealing with diesel engines. The whole combustion process naturally creates acids, and those acids can literally eat your engine from the inside out. The total base number, or TBN, measures how much acid-fighting juice the oil has in reserve. It's like the oil's built-in antacid. Without a high enough TBN, those acids would just have their way with all the metal parts.
Okay, so we've been through a lot of theory. Let's pull it all together and figure out how you can use all this info to walk into a store and choose the right oil with total confidence.
So here it is, your cheat sheet. Rule number 1, always start with the viscosity grade your owner's manual recommends. That's non-negotiable. Then, check the API rating to make sure it meets the performance level your engine needs. If you live somewhere with big temperature swings, from cold winters to hot summers, an oil with a higher viscosity index is definitely your friend. And of course, for a diesel, make sure it has a solid TBN.
And here's the fantastic pro tip for you. These technical specs aren't just for picking out new oil. They can actually be used as diagnostic tools. For instance, if you get your oil analyzed and the flash point is dropped significantly, like by 25%, that's a huge red flag that fuel is probably leaking into your oil, thinning it out and wrecking its ability to protect the engine. When you see that, it is definitely time for an oil change.
So when you boil it all down, understanding the language on that bottle just empowers you to make a smarter choice. It turns what can be a really confusing purchase into a simple, informed decision. So the next time you're standing in that aisle looking at that wall of oil bottles, what's the first thing you're going to look for? Thanks for watching.